Good morning, everybody. So today's lesson 1.5 in the 5th grade Go Math textbook, we're going to be talking about multiplication patterns. We are on page 21 of the textbook, and our essential question today is how can you use a basic fact and a pattern to multiply by a two-digit number? Okay, all right. So unlock the problem. How close have you been to a bumblebee? Well, the actual length of a queen bumblebee is about 20 millimeters. The photograph shows part of a bee under a microscope at 10 times its actual size. What would the length of the bee appear to be at a magnification of 300 times its actual size? Okay, so we can use a basic fact and a pattern to figure this out. So multiply 300 times 20. What's the basic math fact? Well, the basic math fact is 3 times 2. Okay, we know 3 times 2 is 6. So then if we start to use some patterns, so instead of multiplying just 3 times 2, let's go 30 times 2. We still have the basic math fact of 3 times 2, and we have 10 to the first power, because 3 times 10 is 30. So we have 110. All right, so 3 times 2 is 6, and 6 times 10 is 60. Remember the same number of zeros after the whole number as are in the exponent. All right, so then if we go to 300 times 2, we still have the basic math fact of 3 times 2, but this time we have the second power of 10 times 10 to this 10. This time we have 3 times 2 times the second power of 10. Okay, so we're multiplying 6 by 100. So in that case, we would have 600. Okay, so again, second power of 10, our number ends in 2 zeros. So now the final part of this pattern is 300 times 20. So think of the main basic math fact, 3 times 2. And then we have 100 from 10 squared, right? Times the 10 and 20. Well, how many tens is that? That's 3. The second power of 10 and the first power of 10. That's 3 powers of 10. So 6 times the third power of 10. So 6 followed by how many zeros? 3 zeros. Okay, and we see that also in our multiplication problem. How many zeros are there in our multiplication problem? There's 2 in the number 300, and there's 1 in the number 20, for a total of 3 zeros. Okay, so the length of the bee would appear to be about 6,000 millimeters. What would the length of the bee shown in the photograph appear to be if the microscope shows it at 10 times its actual length? Well, in that case, we'd have 10 times 20. Our basic math fact would be 1 times 2. Right? And so we know that 1 times 2 is 2. And then 1 times 2 times 10 to the first. Okay, because we only have 110 here. That would be 2 times 10, which is 20. So what would be 10 times 20? 10 times 20 equals the basic math fact, 1 times 2 times 10 times 10. Okay, because we need to multiply by the 10 and the 20. So how many 10s do we have here? We have 10 times 10, which will be 100. So we have 1 times 2 times 10 squared which equals 200. All right, yes, let's use mental math and a pattern to figure out this one. 50 times 8,000. So our basic math fact is 5 times 8, and that gives us 40, right? All right, so 8 times 5, 5 times 8 times 10 to the first power of 10, which would be 80. Okay, so we're multiplying the 8 by one set of tens. So 5 times 8 times the first power of 10 would give us 400. Now, why isn't it 40? Well, because 8 times 5 is already 40. Okay, so 40, and then it's going to be, that's the whole number, 40, and it's going to be followed by 1 0, the first power of 10, so 400. So now 5 times 8 times the second power of 10. Okay, we're working our way towards 8,000. This is just patterns, all right? So we still get our 40, and how many zeros? 2 zeros. All right, now we have 50 times 800. Our basic math fact is still 5 times 8, but how many tens will we be multiplying by? Well, we have 100 from the previous pattern times the 10 of 50. So how many exponents do we have here? How many tens are being repeated? We have 3. 2 in 100 and 1 in the 10. That's 3. So we have our basic math fact of 40. That's our whole number, followed by how many zeros? 3. And so finally, we can look at the actual problem of 50 times 8,000. Our basic math fact, 5 times 8 times 10 times 1,000. Because that's what we have here in the previous one. When we multiplied 50 times 800, we have 10 to the third, which is 1,000. So 10 to the third times the additional 10 that we're multiplying to get to 8,000 from 800 gives us 40 times 10 to the fourth. Okay. 1,000 is 10 to the third and 10 to the first. So we have 10 to the fourth. We can add the exponents. 3 plus 1 is 4. So 10 to the fourth. So we're going to write 40, our whole number, followed by 4 zeros. I just wanted to make sure it was clear. Okay, so it was 40 followed by 4 zeros. And then every period of 3 numbers requires a comma. So 400,000. All right, 22. 30 times 4,000. So what basic math fact can we use to find 30 times 4,000? 3 times 4, right? Equals 12. All right, so let's go ahead and go through the steps. Okay, 30 times 4,000. So we'd have 3 times 4 equals 12 as the basic fact. 30 times 4, which equals 12 times 10 to the first, which would be 120. If we change it and multiply 30 times 40, we still have 3 times 4, the basic math fact, times 10 times 10. okay, because we have 2 zeros here. So that would be 12 times 10 squared, or 10 to the second power of 10, which would be 12 followed by 2 zeros. If we continued our pattern and we went 30 times 400, again, we have 3 times 4, and this time we would have 10 times 100. Why is it 10 times 100? Because in the previous pattern, we had 12 times 100. This time we're going to have 12 times 10 to the third, or 12,000. And finally, if we just look at the actual problem, 30 times 4,000, we'd have 3 times 4 times 10 times 1,000, which would be 12 times 10 to the fourth. So 12 followed by 4 zeros. So 120,000. Okay, so do I have to use this pattern? You don't have to go through all those steps. We should recognize that this is 3 times 4 times how many factors of 10? Well, the factors of 10 I know by counting the number of zeros in the factors. So there's 1, 2, 3, 4. So 3 times 4 times 10 to the 4th. 3 times 4 is 12, and then there's going to be 4 zeros, because we know that the number of zeros equals the number in the exponent. So 120,000. All right, use mental math to complete the pattern. 1 times 1 is 1. 1 times the first power of 10, 10. 1 times the second power of 10, 100. 1 times the third power of 10, 1,000. And again, we're just noticing that the number of zeros after the whole number matches the number in the exponent. 1 zero, 2 zeros, 3 zeros. So 7 times 8 equals 56. That's a basic math fact. So 7 times 8 times the first power of 10 would be 56 followed by 1 zero. 7 times 8 times the second power of 10, 56, and it would be followed by 2 zeros. 56 times 10 to the third power of 10 is 56 followed by 3 zeros. Six times 5, that's our basic fact, 30. So 6 times what would give me 300? Okay, so my basic math fact ends in a 0. So there's only 1 0 after the whole number. So that's 10. 30 times the first power of 10. 30 times 10. So how do we get 3,000? So 30 is our basic math fact, and is followed by 2 zeros. So 30 times 10 to the second power. And the last one, 6 times 5 is 30. That's our basic math fact. And it's followed by 3 zeros. So the third power of 10. Okay, let's continue. Number 5. Our basic math fact is 9 times 5. So what would be 9 times 5 times the first power of 10? Well, our whole number, our basic math fact is 45, and it will be followed by 1 0. 9 times 5 times the second power of 10, that will be followed by 2 zeros. 9 times 5 times the third power of 10, so 45 followed by 3 zeros. 3 times 7 equals 21. So what is 3 times 7 times the first power of 10? 3 times 7 is 21, followed by 1 zero. 3 times 7 times the second power of 10 will be followed by 2 zeros. 3 times 7 times the third power of 10, 21, followed by 3 zeros. 5 times 4 equals 20. So 20 times what would give me 200? The basic math fact is 20 in all of those. So this is just going to be times the first power of 10, because there's only 1 zero after the whole number. So this time there's 2 zeros. So times the second power of 10. 5 times 4 is 20, followed by 3 zeros. So that will be 10 to the third power. Okay, so use mental math and a pattern to help find the product. 6 times 6, 36. And it's times the first power of 10. So there's going to be 1 zero after the whole number. Okay, number 9, 7 times 4 is 28 times the third power of 10. So it's going to be 28 followed by 3 zeros. 9 times 8, 72 times the second power of 10. So 72 followed by 2 zeros. Number 11, 4 times 3 is 12 times the second power of 10. 12 followed by 2 zeros. 2 times 5 times the third power of 10. 5 times 2 is 10. Times 10 to the third. So we're going to have 10 followed by 3 zeros. So basically we're saying 10 times 1,000, right? 10,000. 13. 2 times 8 times the second power of 10. 2 times 8, 16 times the second power of 10. 16 followed by 2 zeros. 6 times 5 times 10 to the third. So 30. 6 times 5 is 30. That's our whole number, followed by 3 zeros. 15. 8 times 8, 64. Times the fourth power of 10. Okay, so 8 times 8 is 64. And how many zeros will I put after it? 4. 7 times 8, 56. Times 10 to the fourth. 560,000. All right, what does the product of any whole number multiplied by 100 always have? Okay, so what do we know about that? Well, we know that if I'm multiplying by 100, that's the same as saying times 10 to the second power, right? or times the second power of 10. So that means it has to have 2 zeros in the product. So the whole number will be followed by 2 zeros. Okay, so 100 equals 10 squared. And we know from previous lessons that a whole number will be always followed by the same number of zeros that are in the exponent when we're dealing with powers of 10. Okay? The whole number will be followed by 2 zeros. How do I know that? Well, because 100 equals 10 squared, or 10, the second power of 10. And we know that a whole number will always be followed by the same amount of zeros as in the exponent of the power of 10. So if we had said, what do we know about the product of any whole number multiplied by 1,000? We would say it has to have 3 zeros in it. If it was times 10,000, we'd say it'd have to have 4 zeros at the end. Okay. All right. 18. Use mental math to complete the table. So they're telling us one roll equals 50 dimes. And we can think 50 dimes per roll times 20 rolls is the same as saying 5 times 2, the basic math fact, times 10 times 10. Now, where did we get 10 times 10? Because there's a 10 in 10 times 5, right, to get 50. And there's a 10 times 2 to get 20, so 10 times 10. So if we have 20 rolls, we would have 5 times 2 times 10 to the second power. 30. What will we have in 30? 30 rolls. So we're going 50 dimes per roll, and there's 30 rolls. So our basic math fact would be 5 times 3 in this problem times 10 squared. So it would be 15 times 10 squared. And this next one, we'd be multiplying the 5 of the 50 dimes times 4. So 5 times 4 times 10 squared. 5 times 4 would be 20 times the second power of 10. Okay, so you start noticing the pattern here. This one was 5 times 2 times 10 squared. 5 times 3 times 10 squared. 5 times 4 times 10 squared. So what do you think you're going to multiply here? To get 50, it would be 5 times 5. 5 dimes, 50 dimes, times 50 rolls. So 5 times 5 times 10 squared. So 25 times 10 squared. We should also start noticing a pattern here. 10, 15, 20, 25 times the second power of 10. So this next one should be 5 times 6 times the second power of 10. So 30 times the second power of 10. The next one would be 5 times 7 times the second power of 10. 80 would be 5 times 8 times the second power of 10. 40 times the second power of 10. 5 times 9 times the second power of 10. 5. And finally, 5 times 10 times 10 squared would give us 50 times 10 squared. Okay, now remember, the reason we have the increasing whole number is because we're increasing the number of rolls that we're multiplying by 50. This one we did 50 times 20. That was the example they gave us. This next one was 50 times 30. So all we did was take the 5 times 3 times the 100, the 10 times 10. Okay, so if we look at it one more time, we have 50 dimes per roll times 30 rolls. Well, we took the basic math fact, 15, 5 times 3, basic math fact, times how many tens? Well, this is 5 times 10 times 3 times 10. So we're combining the 5 times 3 and the 10 times 10. So we get 5 times 3 times 10 squared. So that's why all of these are 10 squared. Okay. All right, let's try 19. One roll equals 40 quarters. So think of 40 quarters per roll times 20 rolls. So we can take 40 and break that into 4 times 10. And we can break the 20 rolls into 2 times 10. So we can rewrite that as 4 times 2 and 10 times 10. All right, so 4 times 2 is 8 times 10 squared. 4 times 3 would be 12 times the second power of 10. 4 times 4, 16 times the second power of 10. 4 times 5, 20 times the second power of 10. 4 times 6, 24 times the second power of 10. What do you notice about our whole numbers? It's increasing by 4. 4 times 7, 28 times the second power of 10. So why am I still multiplying by 4 every time? Because there's 40 quarters per roll, and I'm just multiplying by the other basic factor. So in this case, it was 7. 7 times 4. In the next one, 4 times 8. 4 times 8, 32. 4 times 9, 36. 4 times 10, 40 times the second power of 10. So let's look at the pattern in number 20. 80 times 6. 80 times 6. Well, I'm going to write that over here. 80 times 6. That's the same thing as saying 8 times 6 times 10 to the first. What did I do? I broke up the 80 and said 8 times 10, right? And 8 times the other factor of 6. So 8 times 6 is 48, followed by 1 0. So 480. 80 times 70. Okay, this is exactly like the rolls of quarters and dimes. So we can take 8 times 7 as the basic math fact times 10 squared, or 10 to, the second power of 10. So 8 times 7 is 56, and it would be followed by 2 zeros. 8 times 8 is 64, and it would be multiplied by 3 zeros. Okay, this last one, 80 times 9,000 would be 8 times 9 times 10 to the what? Well, how many zeros are there in our factors? This one's 10 to the first times 10 to the third. So it would be 72 times 10 to the fourth, which makes sense because there's 4 zeros. Right? So we'd say 72 times 10 to the fourth. All right, 90 times 6 would be the same as saying 9 times 6 times 10 to the first. 540. I just noticed something. Sorry. I wasn't supposed to put the actual answer. I was supposed to match these up. So 480 would be 48 times 10 to the first. 56 would be 56 times the second power of 10. 64 times the third power of 10. 72 times the fourth power of 10. This one would be 54 times the first power of 10. 90 times 70 would be 9 times 7 times the second power of 10. So 63 times the second power of 10. 9 times 8 times 10 to the third. 72 times the third power of 10. All right, 22. What if you magnify the image of a cluster fly by 9 times 10 to the third? What would the length appear to be? So cluster fly. So the cluster fly is 9 millimeters in length. So we're saying 9 times 9 times 10 to the third. Well, the associative property of multiplication says I can group numbers. So I'm going to group the 9 times 9, and that would be 81 times 10 to the third, which is the same as 81 followed by 3 zeros. So it would appear to be 81,000 millimeters. 23. If you magnify the images of a fire ant by 4 times 10 to the third and a tree hopper by 3 times 10 to the third, which insect would appear longer? All right, so we have a fire ant and a tree hopper. Fire ant is 4 times 4 times 10 to the third. And I'll just write fire ant here. All right, so what is the fire ant? Well, 4 times 4 is 16 times 10 to the third. 16 followed by 3 zeros. All right, so the fire ant would appear to be 16,000 millimeters. What would the tree hopper be? The tree hopper would be 6 times 3 times 10 to the third. 6 times 3 6 times 3 is 18 times 10 to the third. So 18 followed by 3 zeros. 18,000 millimeters for the tree hopper. Which insect would appear longer? Tree hopper. 18,000 minus 16,000. 2,000 millimeters longer. 24. John wants to magnify the image of a fire ant and a crab spider so they appear to be the same length. How many times their actual sizes would he need to magnify each image? So fire ant, crab spider. Fire ant is 4 millimeters and the crab spider is 5 millimeters. So basically we want a least common multiple. We want these two numbers to be the same. So we can just make a list, right? 4, 8, 12, 16, 20, 24. Let's try 5, 10, 15, 20, 25, 30. So 20 is in common, right? So what would I have to multiply the fire ant by to get 20? Well, five times. Crab spider, 1, 2, 3, 4 times. So basically multiply them by their lengths, magnify them by that many times, so that they're both magnified 20 times. Okay. And page 24, blood cells. All right, so we have an image of single red blood cell, we have an image of a platelet and a white blood cell. And so blood is necessary for all human life. It contains red blood cells and white blood cells that nourish and cleanse the body, and platelets that stop bleeding. The average adult has about 5 liters of blood. Use patterns and mental math to solve. A human body has about 30 times as many platelets as white blood cells. A sample of blood has 8 times 10 to the third power of white blood cells. About how many platelets are in the sample? Okay, well, we have 30 times 8 times 10 to the third. Well, what can we do to this? Well, we can rewrite this 30 as 3 times 10 to the first times 8 times 10 to the third. Okay, well, let's group the 3 times the 8 as a basic math fact, times 10 to the first times 10 to the third. So that's the same as saying 3 times 8 times 10 to the fourth. We'd have 3 zeros in this number, and we have 1 zero in this one, for a total of 4 zeros. 8 times 3 is 24, and that 24 will be followed by 4 zeros. So 240,000 platelets. (26) Basophils and monocytes are type of white blood cells. A blood sample has about 5 times as many monocytes as basophils. If there are 60 basophils in the sample, about how many monocytes are there? Well, 5 times as many monocytes as basophils. Well, 5 times 60, that's the same thing as saying 5 times 6 times 10 to the first. Well, 5 times 6 is 30, and that'll be followed by 1 0. So 300. 300 monocytes. 27. Lymphocytes and eosinophils are type of white blood cells. A blood sample has about 10 times as many lymphocytes as eosinophils. If there are 2 times the second power of 10 eosinophils in the sample, about how many lymphocytes are there? So 10 times the sample, which would be 10 times 2 times 10 to the second power. Well, 10 times 2 is 20 times the second power of 10. So it's going to be 20 followed by 2 zeros. So 2,000 lymphocytes. And 28. An average person has 6 times the second power of 10 times as many red blood cells as white blood cells. A small sample of blood has 7 times the third power of 10 white blood cells. About how many red blood cells are in the sample? 6 times as many blood cells, and our blood sample has 7 times the third power of 10 white blood cells. Okay, so let's regroup that, and let's use 6 times 7 as our basic math fact, times second power of 10 times the third power of 10. So 6 times 7 is 42. 10, so there's 2 zeros in this one and 3 zeros in this one, so for a total of 5. So 42 times the fifth power of 10, so 42 followed by 5 zeros. 1, 2, 3, 4, 5. 1, 2, 3, 1, 2, 3. 4,200,000 red blood cells. And 29. Kyle says 20 times the fourth power of 10 is the same as 20,000. He reasons since that he saw 4 as the exponent, he should write 4 zeros in his answer. Is Kyle correct? No. There should be actually 5 zeros in his answer. So 20 equals 2 times 10 to the first power. Well, if we regroup that, that would be 2 times 10 to the fifth. So there should have been 5 zeros. Kyle multiplied 2 times 10 to the 4th. Okay. All right, so that's it for 1.5. In our next lesson, we'll be talking about multiplying by one-digit numbers in lesson 1.6. So until then, I will see you soon.